Testing. Audio going through. Testing. Okay, now it's going through. Just gotta double verify. Testing. Audio. All right, we are live. Okay, now it's going through. Not sure how to turn on verify this stuff, but let's get on it. We're gonna create a Miro dashboard. So for all of you who just joined us, what we're trying to do today is practice taking exams. Yay, how are we gonna do that? We're gonna do that by showing you how we do this. So one thing a lot of people don't really know is how do I tackle studying for the physics GRE. So we're gonna look at a physics GRE breakdown. So what I'm taking is something that me and an old buddy of mine actually did the year before he took it. I ended up taking the physics or the GRE specific for math, but we trained for this for a whole summer and consistently improved our grades. And I want to share that. I don't know if much of the guides are out there, and so we could go through that real quick. Okay, bear in mind when I did this, it was almost a decade ago, so I don't know how much it's actually changed. But from the looks of it, it says the physics GRE subjects, so the same for physics and psychology, will be reduced from practically 3 hours to 2 hours. Oh, that's great. Math is still almost 3 hours. You definitely need that whole 3 hours. Um, let's see. Okay, so subjects, tests, physics. Okay, so this is actually where it's very, very important when you start getting into the nitty gritty of things. Okay, this is what we want to keep in mind. Okay, I have my handy dandy notepad right here. And so what we have is we have 70 questions. For the physics GRE. And it says it's based off of diagrams, graphs, experimental data, descriptions, physical situations. And there's an emphasis on physical principles of physics. So this is what I want to highlight, the breakdown. 20% is classical mechanics. Electromagnetism is 18%. Optics and wave phenomena is 8%. Optics and waves. Thermodynamics and statistical mechanics is 10%. So stat, mech, and thermo. Quantum mechanics is 13%. QM for quantum mechanics. Atomic physics is 10%. 6% special relativity. Laboratory methods. And the remaining 9 are specialized topics. Special topics such as nuclear and particle physics, condensed matter, and astrophysics. nukes, nuclear physics, particle physics, PP, condensed matter physics, and that astrophysics. Okay. And so subscores are reported: classical, electromagnetism, quantum, and atomic physics. So let's see. So this is the reason why I highlight this is because you might not have taken some of these other ones yet. At least in my junior year, and typically you'll take this after your junior year because this test comes fairly early on in September of potentially your senior year because you're applying to graduate school that same term. And so personally, at least I went to school at UC Davis. I had only done classes in classical mechanics, electromagnetism, and I think the last term I had done like 1/4 of quantum mechanics. I hadn't done any of these other ones. And so what does that leave you with? 20%, 18, 13%. That's totals up to a little over 50%. You learn a little bit of special relativity in some intro classes. Some of these things you just pick up, but there's 50% of stuff that's basically I haven't even taken classes on, at least at the advanced physics level, right? And so you might want to think, I need to train, I need to do all these other stuff, learn about black holes from astrophysics, learn about the band gaps and the different transition states for, you know, solid or condensed matter physics. And look at the percentage of it. One thing I'll urge for you, and I'll try to find where I could find those breakdowns, is focus on mastering what you already know. Because this is, even though this is the percentage you can gain from classical mechanics, electromagnetism, quantum mechanics, if you master these and aim to get 100% on these, rather than like spending so much time trying to boost these up, which is not guaranteed because the percentage is so low that you'll end up getting a subject that you'll know is so little. And the thing is, because you've already practiced these, you can practice to master them. And what I'll show you once I'm able to find it is that if you score in these topics, right? This maybe some quantum mechanics, right? If you get a 50% score, the percentile you will be against everyone else will be very, very high. High enough to get into a good school. And then these other ones, you can just train them a little bit, but you want to focus on mastering these because these are guaranteed at a higher percentage, right? And so we're gonna look into the scorings of these. It might not be on this website, and so we're gonna have to look for it. But what I just want to share is that it's important to just master what you already know. And so I hope I could find it. Physics GRE practice tests. And so one way to always get around this is to practice for a test is to take the test. There's a Reddit here. Oh yeah. Here we go. Evaluating your performance. Ooh, okay, look at this. Okay, now you've scored your test. Perform this. This is a time. So the way that these are scored is actually compared to everyone else at that time. It says, for example, in the percent column opposite the scale, the scale score of 660 is a percent 57. That means 57% of physics examinees tested between this time frame scored lower than that. To compare yourself with the population, look at the percent next to the scaled score. So like, yeah, this is going to show us a scaled score, and this is exactly what I was looking at for. Is it at the very end? Right here. This is what I wanted to show y'all. Okay. So let me just copy and paste this real quick. Then we'll blow it up. Okay. So this actually tells you like the percentage of people that got these right or wrong for each individual question. And this is okay. This is actually the other part where I wanted. Sorry, it wasn't the other thing, but it was this one. Okay, so look, raw score out of 100, right? If you get 50% of these right, you score above 75th percentile. 75th percentile. So if you master this, you get a 50%, 51%, right? That's what it said specifically here. You will get a 75th percent, you will get a 70. Ugh. Oh, gotta get my marker. If you score a 51% out of 100, you are in the 75th percentile. That means of everyone in the nation that took this physics GRE exam, you were better than 75% of the people. This is very high. This is good. This is really good. And obviously, if you start, boosting some of these other ones up, that's assuming you completely get all of these wrong. This is a multiple choice test, but I think you might get penalized if you actually mark stuff. So that's a big thing. So it's just better to maybe not even guess these, right? But let's just say some of them you just happen to know because you're a fan of Albert Einstein. You get half of these right. You get a quarter of these right. Let's just say you get a quarter of all these other ones right. That boosts you to 75%. If you score 75 on here, you're 96th percentile. Make it even lower. Make it lower. Say that of these you actually get 15% of these right, right? 15 out of the let's say 15 out of the other 50, right? Then that'll be 63%. What does that translate to? So raw score of 65. 91st percentile. Dude, that's your top your top of the top. This is very, very good. Very, very good. And so that's what we're going to have to test for. So, we just read that they reduced the test down from 3 hours to 2 hours. I'm assuming there's probably going to be less questions because answering these 100 questions is very taxing. And it's not until you actually start taking it multiple times that you start going through it quicker. And that's the thing you want to do. You want to be able to do these problems quick because even though you know how to do these, you know classical mechanics, you could figure this out. But when me and my buddy, we actually were calculating it out, so you have 2 hours and 50 minutes of the exam previously, right? So I'll just stick to it because you had 100 problems before. This is before. So they recently changed it. So 100 questions used to have 2 hours and 50 minutes. And that would translate to this was 120 minutes plus 50 minutes. This was 170 minutes. You had less than 2 minutes a question. You had to be quick. You had to just look at a problem, say, I can solve it. It's worth me spending 2 minutes on it. Or you look at it and you're like, bro, I have no idea what the heck this thing's asking me. On to the next one. Immediate. And then you just learn to take the test through sweeps. What I would do, I would take this, right? I take this test, boom. Do I know this problem? Okay, yeah, I could do it. Boom. Do I know this problem? No. And then you would just go through the whole entire test, marking everything. And then what I would do is, after I'm done, I'm like, okay, that took me an hour and 20. Let's do another sweep. And then you kind of almost redo some of them to kind of make sure you can polish them up, or go back to those that you're like, maybe I could solve them, maybe I can't. And so, say for this one, like you skip it, you put a box on it, and that box means something to you, right? And you're like, okay, this, let's work out this problem. How do we do this? Boom. And then once you do these more and more and more, you'll start figuring out the tips and tricks. So what I'd recommend, shoot, find you this website, right? And look, they even have this broken out. So they did this. Maybe my buddy wrote this out. I don't know. 9 years ago. I wouldn't be surprised. It says, how should you study? Yeah, there's solutions out here. Find you exams with solutions on them. Then what you do, you sit down 170 minutes. You just sit through this. Set a timer, 170 minutes, go. Me and my buddy would do this at least once a week during the summer, and then we would try to ramp it up a little bit more later on. And what we do, we would one day we would sit down, take this test, 3 hours, boom. We would just take it, and then after we kind of just leave it at that and leave it. And then the next day we would come back, go through all of them together, and we would just compare these. We'd say, one, what was the answer for it? B, oh, I got C. Oh, you got A, or you got B. You corrected it. And if one of us got it wrong, we would work it out together and show, oh, this is why I got this. Okay, this is why I got this. And then we'd go to the next one. Okay, we got it right. We would just skip it. We don't even bother with it because we'd assume, okay, we know how to do it. That's why we got it right. On to the next one. And so we'd mark these. We'd be like, okay, this one is a little bit hard. Okay, yeah, we got this one. Oh no, we got this one wrong. And then we would just do this over and over. And you're practically taking a test, then learning from it. Then the next day, take a test. Then the next day, learn from it. Because it's too much. I'm not gonna make you do 3 hours every single day, but when you're going back over it, sometimes it could take you almost 3 hours, right? And this is how you get better. The first time I took this test, after the 3 hours, I had barely gone through, I think maybe 70 up to here in the 3 hours, just because I took too long in each of these problems. By the end of it, I had taken at least 5 tests. I was able to go through a full test 2.5 times, like a single test. So I would take the problem, boom, 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 and some of them I would have left blank. Then I'd go through it again, double checking my work. I would still double check my work because remember, you want to master the ones you know you can take on and get those pristine, and that comes with learning to double check your work, right? And we would have more energy. We'd learn the tips and tricks how to do it faster. We learned how to revise and practice for it, and we were able to learn how to just sit through a test for 3 hours. So this is something that I would advise for each and every one of you to do. This is how you get better at taking these tests. So let me highlight that. So this is specific to the physics GRE, right? These things. But down here I'm just gonna write like, what do you need to do? And this works for anything and everything. Whether it's a standardized test, whether it's for a GRE, an SAT, an ACT, or even a final exam or a midterm. Or the MCAT for a fact. Any test, whatever it is, do this strategy. Find the test with solutions. You want to be able to check your work. Find tests with solutions. One. Sit down for whatever time that test says. So, say for example, you have tests for your university. Some professors reuse tests. That's not the aim of it. The aim of it is just to learn how to do these. They're going to tweak the problems. That's fine. Sit down and actually take the test. Only in the allotted time. That's fine. Learn to suffer for those 3 hours. Learn to suffer for that 50-minute exam. Take the actual test and suffer through it. You're going to realize you don't know a lot and you're going to feel dumb. This is okay. It's okay to feel lost. It's okay to feel dumb. It's okay to feel however you're going to feel. Maybe even anxious. You're going to realize you don't know a lot. This is okay. This is the first step to realizing and motivating yourself to work towards this because you will gain this confidence and you will gain the training necessary to get through all these problems. Okay, the next, go through solutions and understand what you got wrong. Some people like just studying to go doing the homework and looking at notes. Do not do that first. Do this. Reason why you do this is because this part, it might not seem important, but this is everything. You will be motivated. You will be driven. You will use that anxiousness, use that feeling lost to know, hey, I didn't know how to do this. I need to know how to do this. When you look at those notes and you think to your exam, you'll say, oh, I need this. I did not know how to follow this particle in this top curve right here. Right here. And when you look at your notes, you'll say, oh, this is how I track this. It will give you motivation and you'll have reason to look at your notes and go through them. If you just look at your notes, everything looks not important. When you take the exam, you look at your notes, things will look important and you will start paying more attention. And so then once you do that, you repeat the cycle. You do this until you can take exams without, and then number 3 goes away. But I urge you to make sure to find exams that are going to be close to your testing conditions, right? If you have a 50-minute exam, you're probably going to have 15 minutes worth of problems. Look at 50-minute problems worth of exams. You might find an hour and a half. That's fine. Work that one. Work it for an hour and a half. Do tests from your university. Do them from other universities. Some will be harder and some will be easier. Definitely challenge yourself. Know how to do the easier ones too, because sometimes it's just learning how to check your work. That's half the battle with a lot of this. Some exams you'll have more than enough time to get through all of it, so learn to check your work. And and yes, this takes a lot of time. I just told you this exam's 3 hours. This is at minimum 3 hours worth of a single training session. If this is too much for you, start off with just say, hey, I'm only going to do half this test, 50 questions, and half that time, right? Maybe you don't have that much time. Okay, maybe you want to split this whole thing up in for a week. Then just split it up. Divide this by 5, right? How much would that be? It would be like 34 questions every in 20 minutes. for one exam, and then you do one exam every a week, right? But you do 5 training sessions for 20 minutes each. You and you do that. You do your 20 questions, then you stop. You look at what you did right or wrong, right? Do this stuff. Actually take the test. You'll feel dumb. Go through solutions, understand how to do each of them, and then repeat the cycle. And just do as many tests as you can. This takes time, but this will save you the headache of just going through your lecture notes for hours on end, thinking you studied a lot and you didn't do jack. People don't study for the conditions, and that's where they fall short. If you want to score high in exams, you have to practice in exam conditions. It's just how you do it. You have to do it like that. And I'm not saying don't look at your notes. Look at your notes after you've done this. Do this a week out from any exam you have. For the GRE or standardized tests, you already have it fixed, right? Do this further out. Do it a summer out. If you could do 10 of these exams, find out every single one that's free and available with answers. Look, this one. There's 4. There's 5 right here. I'm pretty sure I could find some more. And there's plenty of examples, books, solutions to doing this. So this was for physics, right? Um, let's maybe just work through some of these, right? I know some people probably care about looking at some problems. I'm super rusty. I'm doing this so that way I can get good at it too, and I can just show you all how to do it in real time. I am gonna be super slow, and that is okay. I'm trying to get back into tutoring this stuff, and I need to know how to do this. So, I'm gonna take my time with this for now, right? Normally, like I said, I would time it, and I would do this. But for now, we're just gonna do it the old-fashioned way and just do our thing, all right? Rock is thrown vertically up. Rock is thrown vertically up. Dwayne the Rock Johnson. The Rock. With the velocity v naught, assume frictional force is proportional. So friction. The force fric is proportional to alpha v, right? Where v is the velocity of the rock and neglects the buoyant force exerted by air. Which of the following is correct? The acceleration of the rock is always g. So what's the acceleration? This is Newton's first laws. F equals ma. And so we have a is equal to F over m, right? The forces acting on this rock are minus mg minus alpha v. So if we were to say, what's the acceleration? It's going to be minus g minus alpha v divided by m. So the acceleration of the rock is not g. This one's false. A is not true. The acceleration of the rock is equal to g only at the top of the flight. That is true. At the top of the flight, v is 0. That is true. V is true. The acceleration of the rock is always less than g. Well, this is interesting. So when it's flying up, the acceleration. So by less, I'm assuming they mean more negative. And so v is positive. This is less than g, right? This is less than minus g or more negative. So I think what they mean by less than is like magnitude wise. So that's actually not true. So the speed of the rock upon return to starting point is v naught. That is not true. It will have lost energy along the way. The rock can attain a terminal speed greater than v naught before it returns to a starting point. That is not true. Again, it'll lose speed, so it'll actually be less. So yeah, so it has to be B. And if y'all remember, we had already kind of seen it here that the answer is in fact B. Cool. So B. I'd recommend printing these out. I know. I think I don't remember what it said about the new rules and guidelines. Are these taken in person? Physics, the mean, standard deviation. So it's weird. They use this weird thing rather than the percentage. Scaled scores. Oh, look, scaled scores. So yeah, that's percentage wise. Yeah, these percentage wise don't mean anything. Yeah, I don't know what these mean. That's fine. We'll learn them later on for the regular GRE. This might still be taken in person. Oh no. It says beginning in this, they will be administered on a computer. The test will be offered more locations. If we could find practice tests through the computer, we should practice them through the computer. But for these old school ones, I recommend just printing them out and doing it on paper. Because either way, you're gonna want to take notes or do stuff on paper like this, unless they don't give you paper and you have to do it on something like this too, which could be fine. Could be the way to go. Which one did we click? I should really be meticulous about which test this is. Okay. 1986. So we said B. 1B. If you can print these out, if you have a cheap means of doing it, like using the school's printers rather than your own money, do that. But printing them out would be a great way to practice. All right, I'm just gonna keep going through these, and I'm not doing this as fast as possible. The moment I saw this was B, I was just like, I'm sold on it. I would just click that and do a quick check of these. So look, I actually wrote down the physics of this stuff and then compared it to them. Might not be the fastest way. Notice I've already taken 5 minutes working this problem. Probably not the best use of time, but I want to explain everything for y'all and maybe the thought process. We'll go through them quicker at some other point, all right? Okay, satellite orbits the Earth in a circular orbit. Satellite. This is my satellite, and this is Earth. Okay, y'all get it. An astronaut on board perturbs the orbit slightly by briefly firing a control jet towards the Earth's center. So my man's has a rocket. Let's go. Afterward, which the following is true of the satellite's path? It is an ellipse. It is a hyperbola. It is a circle with a larger radius. It is a spiral with increasing radius. It exhibits many radial oscillations per revolutions. So what's interesting is this thing has a normal trajectory in this direction, right? And since he put a force in it inward, technically it already has a force inward, right? Technically, no work is being done because work the work done is the integration of the force in the direction of movement. And since the force is inward, no work's being done. And this is actually something you kind of learn in some classical mechanics, like orbital mechanics. I don't believe it's a hyperbola because it doesn't completely throw this out of trajectory. It says perturbs slightly, perturbs orbit slightly. So a hyperbola would mean that this gets way out of control. It's like, right? Boom. And so hyperbola is out. An ellipse, that's a possibility because it still remains in a shape resembling. Remember, it says slightly perturbed, so it's gonna only be moved a little bit outside of the orbit, right? It says it's a circle with a larger radius. If it's a circle with a larger radius, that means that the potential energy would have changed. And in order for it to maintain the same velocity, it would have had to have gone slower. And that means that work would have had to have been done. And that can't be the case. So C is also out. Um, I could maybe be more explicit. So remember that total energy your system's going to have is a combination of kinetic energy plus potential energy. We know no work was done, so your kinetic energy has to remain the same, at least initially, right? If it ends up oscillating around here, then it's gonna be an exchange between these two. But what you are doing, let me think about this a little bit. Potentially, there actually is some work being done. I said no work's being done, but there is work. Because you're pushing this inward. Okay, let's just keep thinking of it. Okay, it says it is a spiral with an increasing radius. That would mean it was going outward. I don't think that's going to happen. It exhibits many radial oscillations per revolution. So as it's spinning, this thing goes. Maybe. I'm more inclined to say it's an ellipse, just because of from or so it's going to be either A or B or E. And I think the way this exam works is if you guess wrong, you're actually dinged. And you're only dinged a little bit. Let's check that. Let's check this again. I could be wrong. I could be thinking of a different standardized test. Let's look it up. We have technology. Yeah, I don't remember. We'll learn that later on as well. But let's look at the answer. Who's A? You said it was A or E. That's probably what I would have guessed. I should have said that, but I knew it was gonna be A or E. I probably did say it was gonna be A, but I wasn't super confident in it. And that's fine. On to the next one. 3. Okay, blue light. A transparent material has a relative permittivity of 2.1 and a relative permittivity of 1. What? Speed of light in a vacuum is c. Base velocity of blue light is unbounded. Medium is blank. So light will never travel above the speed of light under, standard classical conditions. There's probably some weird scenarios where, yeah, it does. But, so we know it has to be less than these. I'm inclined to say it's probably going to be something like this. Like maybe 2.1. I'd just totally guess D. If you're allowed to guess, might as well take guesses. Um, yeah, let's see what it is. And later on, like we said, you could figure it out. Yep, 3 is D. Cool. And again, if you don't know it, just skip it. Do what you could do. I'm gonna skip some of these. I'm just writing down guesses right now. I just want to work through this. They're all positive, represents a wave whose amplitude is 2a, whose velocity is the negative direction. Whose period is t over lambda. So it's not c because the units don't match up. This t is time. This lambda's distance. This is incorrect units. So it's not c. Could be a, could be b, can't be c. The speed is x over t. It can just purely based off of units, right? Speed is that. Could be that because of units. Okay, I'll say it's not d because those are independent variables. So you wouldn't ever say x over t like that. For the speed, it can be that though. And then so let's look at the velocity. So we'll just play around with it. Let's say the height peak at time equals 0 when x is 0. The velocity is the negative x direction. So let's think about this. For sine, the trough. Let's just look at this real quick. Let's just say minus x, right? How does this look like? If we started moving time, so let's say this increases. This is 1 now. When x equals 1, it'd end up moving this way. Yeah, so the velocity can be in the negative x direction. What is even the question? Oh, yeah. I feel like it could be potentially moving in the x direction. Am I thinking of this wrong? I guess we could just look at it. Don't even bother. The first test, just chill, man. Just chill. We're here just to chill. You start freaking out, that's fine. E. Okay. Yeah, the speed is this. So I guess it moves in the positive X direction. So that's something I definitely need to work on. And that's good feedback. Hey, I need to work on my graphs, right? And you can make those notes to yourself. That's what I'm saying. If you print this out, you can then write on this. 5. Ooh, I like this. Two small spheres, A and B, a mass of 3. A, B, M, M, L, L. H naught is the height difference. Two small spheres. This one's M, this one's 3M. Ooh, it's heavier. Drawn to the side, raised that much, collides with B, and they stick together and they swing at a maximum height H equal to what? So right away, I can see this is going to be a momentum transfer problem, right? So what's the energy that this one has relative to this? We'll say this is 0. This one has M H not G. It's all the potential energy it has. So at the bottom, when it hits, all the energy is going to get converted to potential energy. So you always want to deal with stuff. This immediately classical mechanics just always think momentum and energy. Those are your friends. Right now we're thinking energy. Okay. So MGH, MHG, however you want to think about it. Then here it's going to be purely kinetic energy. Hold up, is that true? We're going to assume no energy is lost to them getting stuck together. Is that how we're going to do this? Well, either way, we know we'd have mg and then a velocity of some sort. And then after that, you have 4m. Sorry. Okay, let's forget energy for now. Let's look at momentum, which denoted as p. So the momentum you have from this going from top to bottom is still actually mgh. That's the energy. It all gets converted to kinetic energy at the bottom. And so when you solve for v, you get v is equal to 2gh naught square root, because you multiply both sides by 2 after you divide by m, then you square root both sides. So this is the v, the momentum you have of ball A at the bottom is mv, and then after you will have 4m, so I'll call this initial, and then v final. So v final is equal to v naught divided by 4. Okay. What we want to see is like, well, what's the final height? Right? And so you kind of have this equation backwards, where you have your ball stuck together, had an initial velocity this way. How high is it going to go up? What you end up seeing is you have the same equation. 1/2 4m vf squared is equal to, move this over, 4mgh. We want to relate this h to the other one, right? And so this v squared is going to be that value. B naught 16 and then we solve this, right? This is 32 divided by 4, that's 8. Let's guess we could just straight up cancel these two. So B naught divided by 16 is equal to GH. And what do we know? We know B naught V naught V naught is equal to 2H G naught. GH naught. So V naught squared is equal to 2GH naught. So we plug that into here. We're left with 2GH naught divided by 16 is equal to GH. Divided these, we have H is equal to H naught over 8. So it should be B. B, final answer. Let's see what we get. Yo, we got it wrong. This is A. What did we mess up? Oh, we forgot this 2 right here. Do you see this 2? There should have been a 2 over here. Down here. Times 2. And then these 2's would have canceled out, and then we're left with 16. You see, this is a simple problem. We could have gotten right, and we could, we just have to learn to double check this. I think I did some redundant work. I think there could have been some easier substitutions. So that's something we could also revisit. Say, hey, what's a quicker way to solve this? And it's kind of hard to see that insight. I haven't done these problems in a while. So I first started with energy. Then I'm like, wait, let me start with momentum. You may ask, well, why didn't you just use energy the whole way through? You probably could do it that way. Probably was faster. But we're moving on. You don't have to get so caught up in all these. You're never gonna get through all this, right? Go through it, work on it another time. But I think for now, I'm probably gonna call it. I'm gonna try to do this a lot more often, just so I can work on my skills. I can get through more of these exams, and hopefully help others out on this. In the meantime, I wish you all a good night. Take care and peace.